Hello everyone. My name is Praveen, and today we are going to look into the problem of finding two elements such that their sum is closest to zero. So, on this particular problem, we are going to initially understand the problem statement and solution approach, what we are going to do, followed by the pseudocode and its data structure. Further, the Python code implementation, and forward along with the edge cases on our code and efficiency analysis of our code, finally the conclusion. So the understanding problem statement, it's very simple. So wherein we have given the two elements, we have given the list of positive and negative integers, wherein we have to find the element whose sum is closest to zero, not exactly the zero. So we can see through the test case that if the list of integer in the sample input, wherein we have to find the two numbers which sum is close to zero. So how we are going to approach for the solution? So we use a function called find closest sum pair, which tackles our problem of finding two elements in a list. And here's the breakdown of it, wherein initially we do the initialization, and the function initializes several variables. So the left and right pointers, wherein it iterate through the sorted list, starting at the beginning and end respectively, and the closest sum variable, wherein it stores the current minimum absolute difference between a sum and zero, and also a best pair variable, wherein it stores two elements with the closest sum. So it will be initially empty. We also use a two pointer technique in our code, wherein the logic lies in while loop that will continue as long as the left pointer is less than right. And inside the loop, we have a current sum variable that is calculated by adding elements at indices left and right, and also the absolute value of current sum that is compared to the current closest sum, and also the corresponding element at indices left and right are stored in best pair as the current closest pair. So this will be our pseudocode. So if we look into our pseudocode, initially we do the sorting, wherein the list of numbers is sorted to enable an effective two-pointer search. Further, we do the two-pointer initialization, wherein one at the start to the left side and one at the end to the right side of the sorted list. And we also do the loop and condition checks, wherein the left pointer is less than the right pointer. The sum of the element at this pointer is calculated and compared against the closest sum form so far, so that we can see that if current sum is 0 or closer to 0, we'll update the closest sum and the best pair. So if the sum is greater than 0, then we'll decrease it by moving the right pointer to the left. And similarly, if the sum is exactly 0, then that will be your optimal solution, so the pair is returned immediately. So we provide the return statement after exiting the loop, so that we return the pair that has the closest sum to 0. If you see this pseudo code, and further if you want to go to the data structure, so we have a few data, in our data structure input list of numbers will be a primary data structure, and that contains the list of integer for which we need to find the closest sum to 0. And also we do have a pointers left and right, wherein these are integer variables. They are used to iterate the through the numbers list using the two pointer technique, and left starts at the beginning of the list and right starts at the end of the list, wherein the index of the last element. And we then have a closest sum variable, also the best pair variable. The closest sum, it's a floating point variable like float in Python, and that is initialized to positive infinity. And also it stores a minimum absolute difference between a current sum and 0. When it comes to the best pair variable, It is like a tuple in tuple as in Python, and that is actually initiated to initialize to null to represent no pair found initially, and it's update throughout the loop to store two elements with the current closest to some zero. And this will be our data structure, and this will be our code. And from our code, we can see how we are initializing the left and right pointers, and also our loop throughout the list, and where we are returning the pair. So we are returning the pair only after the loop, wherein we found the difference between a current sum of sum of the current sum that is closest to zero, and then we are printing the result. When it So in our code, let's see the edge cases that may occur. If there is a possibility of edge case that may occur, so there are couple of usually there are couple of edge cases, that is empty list and single element list. However, in our code we use a two pointer technique, so that efficiently iterates through the sorted list, so making those specific edges cases irrelevant in the context. Also, our approach wouldn't even enter the main loop of while loop. So in these cases, it prevents error. So completely, it avoids the empty list and single element list. And when it comes to efficiency, if you see the time complexity, so we first sort the list using the sorting algorithm like quicksort or merge sort. So these algorithms have an average and worst case time complexity, and also the two pointer loop, wherein the it iterates through the sorted list at most of the n times. So in each iteration, constant time operation like addition, comparison, and pointers movement occur. And when it comes to the overall time complexity, we can see the overall time complexity of the code will be 0 of n log n, so which is offers a efficient solution when with regards to the time complexity. Also, the in when it comes to space complexity, in worst case, this space complexity can be 0 of n, wherein the depending on the specific sorting algorithm used, such as quicksort uses recursion, which can replace extra space for the call stack. So both time complexity and space shows the good efficiency. So I'd like to conclude that in our presentation, we explored an efficient approach to find the two elements in the list whose sum is closest to zero. And also we used a find closest sum pair function, which utilizes a two pointer technique, and it is iterated through the sorted list, efficiently finding the element with the closest sum. Also, we presented our solution effectively that finds the closest sum to zero in a list. So, by demonstrating efficient use of sorting and two pointer technique. Thank you.